let's continue with example 4. This is the question. Integrate dx over square root x squared plus 2x minus 3. So we know that this question should be using trigonometric identities because you have a square root and inside here you have certain function. However, this is not in terms of constant squared plus or minus variable squared because this is in terms of quadratic function. So let's take this function here and let's perform completing the square. So now let's do completing the square. The one with your x here, let's put it into a completed square. So for b, you need to divide by 2. So 2 divided by 2 is just plus 1. So now you're left with x plus 1 squared. So you need to minus back the squared here. So minus 1 and rewrite back minus 3. So let's solve the back part here. So you're left with x plus 1 squared minus 4. So this is the completed square. So let's rewrite it back here. So now you have integrate 1 over square root of x plus 1 squared minus 4 dx. So now it is very clear to us that we have the term of variable squared minus constant squared. Let's take it out here. Okay, so now you have square root of x plus 1 squared minus 2 squared. So x plus 1 here is your variable, 2 here is your constant. All right, so let's see here. Your x should be equal to x plus 1 right now, and your a now is equal to 2. So let's fill in our equation here. The equation that we should choose is x equal to a secant theta. So let's fill in this part here. So your x now is equal to x plus 1. Your a now is equal to 2. So you have x plus 1 equal to 2 secant theta. So let's rearrange a bit. We want only x. So x now is equal to 2 secant theta minus 1. And let's differentiate. This is equal to 2. Differentiate secant theta is secant theta tangent theta. Differentiate minus 1 is just 0. And write the theta. So now we are ready to write everything now in terms of theta. So now we have integrate 1 over square root. And let's fill in our x plus 1 here, which is 2 secant theta squared minus 4. And let's rewrite our dx. Dx is 2 secant theta tangent theta d theta. So now everything is in terms of theta. So let's open up this one here. This should be 4 secant squared theta minus 4. So I hope it is clear to you that this is a common term 4. So let's factorize it here. Okay, so everything else is the same. Just factorize 4 here. So here you are left with secant squared theta minus 1. So now we know that we can split the function in your denominator because cert a times b is just cert a times cert b. You can just split the square root here. So let me write here. This is cert 4. This is cert secant squared theta minus 1. So cert 4 is just equal to 2. Cert secant squared theta minus 1. This is just equal to tangent squared theta. Because according to the identity, secant squared theta minus 1 is just equal to tangent squared theta. So let's rewrite this here. This denominator will become 2 cert tangent squared theta. So now 2 and 2 is a common term. You can cancel out. So this one here also can be cancelled out. Square root and your squared here. So you're left with integrate secant theta tangent theta over tangent theta d theta. So again, you have a common term. Let's cancel out. So you're left with integrate secant theta d theta. This is very straightforward to solve. Integrate secant theta d theta according to the formula list is equal to ln in modulus secant theta plus tangent theta plus c. However, this is not your final answer yet. This is all in theta. We don't want our answer in theta. We want our answer in terms of x. So what should you do? We need to back substitute again, but now we will use a right angle triangle. So now let's focus back whatever we let in the beginning, which is x plus 1 is equal to 2 secant theta. This is what we have. So from here, let's adjust a little bit. Secant theta is equal to x plus 1 over 2. And since this is secant, cos is just flip this up. So cos theta is 2 over x plus 1. So let's draw a right angle triangle. And this is your theta. So cos is adjacent over hypotenuse. This is 2, your adjacent, and your hypotenuse is x plus 1. So now we can find our opposite, all right? So this is just square root of x plus 1 squared, hypotenuse squared minus adjacent squared. So now this is just x plus 1 squared minus 4. Okay, so this is the answer for your opposite sign. So now we are ready to open up. Let's open up ln modulus secant theta. So we already have the value for secant theta, which is x plus 1 over 2 plus tangent theta. So now let's find out what is tangent theta. So from here, let's read our tangent, opposite over adjacent. So this is just square root of x plus 1 squared minus 4 over 2. Okay, opposite over adjacent. So let's fill in at your tangent theta here. This is just this value here, set x plus 1 squared minus 4 over 2. Close your modulus and write plus c. Therefore, this is your final answer. So be careful for this question. You need to substitute back using the right angle triangle because this is not definite integral. Okay, this is indefinite integral. So that's the end for this chapter. Assalamualaikum warahmatullahi wabarakatuh.